Hi guys, gotta just set that up properly. All right, so here is our video number 2 for solving systems by elimination. Our first video, we were watching the taco truck, or you watched the taco truck problems, and we were able to ask sort of questions on how can we get rid of one of our variables when we have various tacos versus drinks and blah, blah, blah. And we were able to figure out that, oh, if we combine the two equations, we could see sort of the difference between the two equations because both of them had the same amount of a certain taco or drink, and we were able to play around with that. So now we are going to put that to a more abstract idea and just look at it with simple equations and not actually put it into the context of the taco truck problem. So now we are going to look at this and we're going to actually put some words to that process that we just did. So some of the words to that process are these right here, these 4 steps. Let's write these down if you need them, so that way you can start to have a step-by-step process. Now, I understand not everybody is going to need to follow along with these rules. You'll be able to figure them out on your own, or you'll be able to do this in a slightly different capacity and still get this done and done well. However, these steps can be very, very helpful for the majority of us trying to work through these problems. So step 1, write the systems of equations so the like terms are aligned. Cool, awesome. We understand what that means. Essentially, the x's need to be aligned, the y's need to be aligned, constants need to be aligned. Step 2, add or subtract to eliminate a variable. Ooh, we played around with that in the taco truck problem. We played around with that in substitution as well. And then we're going to solve. And it says right here, there's like fine print that might be hard to read. You may need to multiply one or more of the equations to be able to eliminate a variable properly. And we're going to actually look at that more in the next 2 videos. Less so, or we're not even going to look at it now, but we'll look at it more in the next 2 videos. Step 3, we're going to substitute the answer to step 2 into one of the 2 original equations and solve. And step 4, we are going to write our answer as xy, and we are going to check our work. Okay, so we have this set of equations. X minus 2y equals 19, and 5x plus 2y is equal to -1. If we look at these 2 equations, I'm totally off the screen. If we look at these 2 equations, we can see that 2y is visible in both of them. That means to make our lives a little simple, let's focus on those and trying to eliminate those. It's really important with solving systems by elimination that you identify one major thing that you can try to eliminate easily. The goal is ease, because if it's not easy, it's a possibility that one of the other methods of solving, graphing or substitution, could be better for this situation. At the same time, systems of elimination, just like substitution, will work every single time. It just sometimes takes more work than other times. All right, so if we look at the 2y and the 2y, we will be able to combine those 2 and get rid of them, or not get rid of them, cancel them out, essentially make them 0, a non-issue, and we'll be able to solve for x. We'll be able to eliminate them. Sometimes you'll also hear elimination be called combination method. Essentially, we are combining these 2 equations. So just be aware that you might also hear me say combination every once in a while, or combining the equations. All right, so let's check and see if step 1 is done. Step 1, write the system so like terms are aligned. X's are aligned, Y's are aligned, constants are aligned. What's also really important is that you pay attention to also the operation signs are aligned and the equal sign is aligned. If it's not, if this equal sign and the subtraction sign were perhaps flipped, that means you don't actually have everything aligned properly, and you're not going to be able to solve that systems of equations properly. So it's really, 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 really important that you don't make that mistake. You make sure your x's are aligned, the operation signs, y's, equal signs, constants. Cool? Cool. After that, we need to add or subtract to eliminate a variable, and we're going to solve it. If we look at these 2 equations, we need to decide if we want to use addition or subtraction to solve this. If I look at this, -2y, I can technically rewrite that as plus a negative. -2y plus 2y, if we added those together, they become 0y. If we subtracted them, -2y minus 2y, I get -4y. That doesn't solve my problem of having 2 variables. I need to have one variable because our goal is to combine these two equations so we have one variable that we can solve for, right? Our goal is always to eliminate one of these variables so we can solve. So if I add these two equations, this y term will disappear, or it will cancel itself out. It will become a non-issue. So let's do just that. We're going to add these two equations. 1x plus 5x would get me 6x. And as you can see, I'm just adding vertically. I'm combining them vertically. Negative 2y plus 2y gets us 0 y's. And I'm always going to write this out the first time so that way I can see that placeholder and I can be like, okay, yes, I did the right work. 19 plus a negative 1 would get me 18. So now I can say, okay, 0 times y is just 0, so I really don't have to worry about this. I get 6x is equal to 18. Divide by 6, I get x is equal to 3. There's one of my answers. It's not my whole answer though, right? So if I were to write an ordered pair, I get 3 comma a number I don't know. Okay, wow, that 3 is really messy. I'll write it in the front. 3 comma a number I don't know. And so because of that, I'm not finished. I need to have a complete ordered pair. So a lot of people will tend to stop at this point, be like, oh, that was a ton of work, which it is. It's a ton of work, but I'm still not done. So you have to finish. Step 3, see, we're only partway through the steps. We're only halfway done. Step 3, I need to substitute this variable I just got from step 2 into one of these two original equations, and I need to solve. Now, when you go to substitute, I highly recommend you doing one of the equations that's maybe a little bit easier to deal with. This top equation is a little easier to deal with because I won't have to multiply my x value if I put it there. So I'm going to put the 3 in that. So I get 3 plus a negative 2y is equal to 19. I'm going to subtract 3 from both sides. I get negative 2y is equal to 16. Divide by negative 2, divide by negative 2, and I get y is equal to negative 8. So I'm done, right? No, I need to check my work. It's really important. So you can check your work in one of two ways. You could potentially put this system of equations into a graphing calculator or something like that. You can find where they intersect and see if it's the same. I want you to do that after you've actually practiced this process, just so that way you can make sure that you've done this. It's important to have multiple tools in your toolbox. Or you can put these numbers back into the equation and see if they work. So I'm going to do the latter. I'm going to put these numbers back into this equation and see if they work. So I'm putting 3 in for x. Y is negative 8. So 3 minus 2 times negative 8 is equal to 19. 3 times negative 2 times negative, or minus 2 times negative 8. 2 times negative 8 is negative 16. So I have 3 minus a negative 16, or 3 plus 16. 3 plus 16 is 19. Yay, that one works. Sounds good. Let's check this one. 5 times 3 plus 2 times negative 8. 5 times 3 is 15. 2 times negative 8 is negative 16. 15 minus 16 equals negative 1. We're good. Both of them work, and we have our answer, 3, negative 8, using elimination. We have 2 more videos to practice this, and those examples that we're going to be doing are going to get consecutively harder. So we're going to get a little bit more difficult with the next one and the one after that. So check them out. If at any point in time you feel like you are good to go, you can start working on the must-do practice problems. If you need, you can use these tutorial videos to reevaluate if you start making multiple mistakes. Thank you for watching. Bye.